Hello everyone, and today we're going to be doing the March 2024 MCQ paper, question 8. So this is related to relative speed of approach and relative speed of separation, and when we have a perfectly elastic collision. So the first thing, we need to know basically which diagram shows us that there's a perfectly elastic collision. So first of all, let's learn what it means by relative speed of approach and separation using a diagram. So if I have an object here going 5 meters and I have an object here at rest, what would be the relative speed of approach? That would be the speed of v1 and this is speed v2. It would be v1 minus v2. So this is a formula of relative speed of separation. And now, similarly, if you think about it in terms of separation, it would be m and then n, and then this is v1, v2. After the collision, all of the energy momentum of v1 is transferred to n. Now it's moving at 5. So the relative speed of separation would be v2 minus v1. Now, many people teach you other alternative formulas for when they're in different directions, but it's much easier to learn this and define an axis. So we can define this as conventional as positive and the other side as negative, right? So we can say the relative speed of approach will be 1.3 minus 0.50. So this will be equal to 1.8 meters per second. Similarly, relative speed of separation should be then what? 1.8. So over here, how would we calculate? 0.58 minus 0.22. We already know that's not going to be correct. Over here, similarly, 0.40 minus 0.40, they're moving together, so there's none. Our answer, 0.99 minus 0.19, because it's in the other direction now. However, this still is not equal to 1.8, but if you see here, 1.30 minus 0.50, is equal to 1.8. Hence, our correct answer here will be option D.